Section 4.6, Example 3 on page 273, we have you can model many real-world situations by writing and graphing systems of linear inequalities. Some real-world situations involve 3 or more restrictions, so you must write a system of at least 3 inequalities. For example 3, we have you are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball. You must spend at least 1 hour and a half on homework. What is a graph showing how you can spend your time? We can let x be the number of hours playing basketball, so we'll label the x-axis as number of hours playing basketball, and we'll let y be the number of hours doing homework, so we will label the y-axis as number of hours doing homework. Using our labels and the fact that we can spend at most 6 hours daily playing basketball and doing homework, we can say that the number of hours playing basketball, x, plus the number of hours doing homework has to be less than or equal to 6. At most means I can spend 6 hours or less, so we use less than or equal to. Now, to be able to graph this inequality, we want to get y by itself. Therefore, we can subtract x from both sides. X minus x gives us 0, and we can bring down our y. 6 minus x can be written as negative x plus 6, so that we have the x in front. And since all we did was subtract x, we keep our symbol the same. So we still have less than or equal to. Therefore, we have y is less than or equal to negative x plus 6. We can start by looking at our y-intercept. We have plus 6, so we're going to start our boundary line up at 6 on the y-axis. Next, we'll take a look at our slope, which is negative 1, or negative 1 over 1. This means we're going to move down 1 into the right 1 over and over again to get some extra points for our boundary line. Because we have a less than or equal to symbol, we're going to have a solid line, and we will shade below. So here's our solid line, and shading below would be this triangular region. Since we want to spend less than 2 hours playing basketball, x represents the number of hours playing basketball. It says we want to spend specifically less than 2 hours, so we're going to use the less than symbol. So we'll have x is less than 2. Since we have the less than symbol, we are going to have a dashed line going through x equals 2, so it'll be perpendicular to the x-axis, and we're going to shade down. Shading down for this inequality means we're going to shade to the left because the numbers that are less than 2 would be to the left of 2. For our last inequality, since we want to spend at least 1.5 hours on homework, we have y is the number of hours spent doing homework, and we want at least 1.5. So we will have y is greater than or equal to 1.5. At least means we can spend exactly 1.5 hours or more doing homework. To start graphing this inequality, we will find 1.5 on the y-axis and mark that with a pink dot. And because we have greater than or equal to, we will have a solid line and we will shade above the line. One thing I want to note about this graph is that we're only looking in the first quadrant, so we're only considering positive values because we're talking about hours. So we don't want to consider negative hours because that would not make sense. Since we have 3 different inequalities graphed on the same graph, we have quite a few different regions to look at. Region 1 contains the blue and pink shading. However, in order to be our solution region, we need all 3 colors. Region 2 has just the pink shading. Region 3 has no shading. Region 4 has just the green shade. Region 5 has the blue and green shading. Region 6 has the blue, green, and pink shading. So this has all 3 colors. And just to double check, Region 7 only has the green and the pink shading. We're missing the blue in Region 7. So our final answers will come from Region 6. The work for this problem is written out on the next few slides. Something I would like to point out about their final graph is that they only shaded the region that was the final answer region. If you were doing this digitally, say on an iPad, you can easily erase all of the highlighting that you did for each part and then only highlight your answer region. If you're doing this on a piece of paper and you've already highlighted, you can always circle or mark like I did in my example.